Let's now find the logarithm of the cube 1 over the cube root of 4 with base 2 square root of 2 and somehow pull this off without a calculator. The most direct approach is to think about just simply the definition. So let x be equal to the logarithm of 1 over the cube root of 4 base 2 square root of 2. So that means that 2 square root of 2 to the x power has to be equal to 1 over the cube root of 4. Now this looks like a daunting task. It looks like a daunting task. The way that we make this less daunting is we write everything in terms of powers of 2. So 2 times 2 to the 1/2 power, whole thing to the x, is equal to 1 over 2 squared, and more precisely the cube root of 2 squared. So on the left-hand side we have 2 to the 3/2 power times x. 2 to the 3/2 is what's inside the parentheses, and by the law of exponents we multiply by x. On the right-hand side we have 2 to the negative 2/3 power. And so matching the exponents, we have 3/2 x is equal to negative 2/3, so that x is equal to negative 4/9. And so this can be computed without a calculator by just simply using the definition of logarithm. A probably more conventional way of doing things that does not directly appeal to the definition of logarithm is to change the base. So the logarithm of 1 over the cube root of 4 base 2 square root of 2. Let's change the base, and it really doesn't matter what base I change it to. Let's change it to natural log of 1 over the cube root of 4 divided by the natural log of 2 square root of 2. From here we recognize that, just like before, 1 over the cube root of 4 is the same as 2 to the negative 2/3. And 2 times the square root of 2 is the same thing as 2 to the 3/2. So this is equal to negative 2/3 times the natural log of 2 divided by 3/2 times the natural log of 2. And so natural log 2 cancels from top and bottom. That's why it really didn't matter what base I used on the first step. I could choose log base 10 or log base 1000 or any other base, because when I get to this step the logarithms will cancel. And so finishing the proof, we get that this is equal to negative 4/9, as before. So the change of base formula is basically the same logic that you see on the left-hand side in red. This is writing in terms of exponentials. In green, it's writing in terms of logarithms, but logically it means the exact same thing.